All right, so today we're going to be looking at writing absolute value functions. So what you need to know in terms of when you write this is you have to have essentially two parts to write the equation. Okay, you have to have this a value, and then you have to have this h and this k value. Okay, once you have those three parts, then you can write an equation for the graph. Okay, now for finding the vertex as we know is going to be hk. Okay, for slope, we're going to need the 2 points to do this, and from Algebra 1, you learned this particular formula called slope formula. That's useful, but I will show you a second method on how to find the a value. That's actually going to help you with a future concept we're going to do, and actually comes up after this particular unit. So the other thing you have to pay attention to is whether the a is positive or negative, and that's knowing if it's a minimum or maximum type graph. Okay. So if you're given a graph, for example, okay, kind of like example 1. Let me kind of zoom out here for a second so I can see the whole thing. Okay. Then what you're looking for is this particular piece that I'm going to look for. I set this up in a 1, 2, 3, 4, 5 fashion so that you know how to do it in which order. That way it's a little bit easier for you. Okay, it gives you something to kind of work with. Okay. So like for example, the first thing it's going to ask for is what is the actual vertex, hk? Well, if I look at my graph, I know my vertex is this particular point sitting right there. And that point happens to be sitting at 2, 2. Okay. Since that's the case, then I know my vertex point happens to be 2, 2, okay, for my hk. Well, what is the slope? Well, in order to do the slope, you have to have another point somewhere. And if you look at your graph, there's a couple of possibilities. I could use this point right here. I could probably use this point right here to get what I want. It doesn't really matter how I do this. So what I'm going to do is, from Algebra 1, you learn something called rise over run. So if I use the first 2 points, for example, I know that I will go up 1, and then I'm going to run it 1, 2, 3 units. So my slope for this particular line right here is 1/3. Okay, 1 over 3. So here's the thing. I know my slope is 1/3 for one of the lines. Okay. If I did the same thing on the other side, if I pick this point right here, for example, and I did the same thing, then I know I would go down 1 and run 3. So then my slope for this line here would be a negative 1/3. So that's the case. I've got two possibilities. I've got a 1/3 and a negative 1/3. Okay, that's my two slopes. So the question is the slope going to be positive or negative? Well, here's the thing. If you look at the graph itself is what we call a maximum graph. Okay, and since it's a maximum graph, we know that the a value has to be negative because a maximum graph is a reflection, which is going to be a negative a value. Okay. So when we write the actual function, here's how we're going to do it. We know it's f of x, and since we know that it's going to be the negative 1/3, then I know it's going to be negative 1/3. Okay. Absolute value of x minus h, x minus, this is h, this is k, forgot to write that a minute ago, 2, and then plus 2. Because this should give me a shift to the right, and this should give me a shift up. Okay? And the graph, if you look at the graph, you know, it has a shift up and it has a shift right. but it's also reflected, which means that the A value here should also be negative to make it reflected. Okay, this is the whole purpose of transformations, is to actually understand how to write the equations based on that. So now once you have that piece, you're going to probably be asked to evaluate something. And when we evaluate, all that means is we're going to take our equation and we're going to actually plug it in. So like for example, I can do negative 1/3 at the absolute value of 10.2 minus 2 absolute value plus 2. Okay, and you're going to do a little bit of math. And again, it would be negative 1/3 absolute value of 8.2 plus 2. I think I'm going to run out of space here, so I can get a little bit smaller. So then it's going to become negative 1/3 times 8.2, because absolute value of 8.2 is 8.2 still, plus 2. And if I do that in the calculator, which I just realized I forgot my calculator, so I'm going to pause for a second here. Oh, I can't pause. I'll be right back. Give me 2 seconds. Anyway, that's poor planning on my part. I forgot to grab the calculator here. So if I do negative 1/3 times 8.2 plus 2, then I get a negative 7.33. So a negative 0.73, repeating, or a negative 11/15. Okay. Now I know the answer question is going to be, do you go in a fraction or a decimal? I'll take either answer because I didn't specify, but since my number here to start off with was a decimal, then the answer couldn't be in decimal. If it had been a fraction, I would have left it in fraction form. Okay. So at this point, if you want to pause to try the next one, now's the time to do it. Okay. So the vertex, again, if I'm looking at my graph here, is right there. It looks like it's at negative 1, 2. So that's my H, that's my K. The slope, well, again, if I pick a point, let's just say I pick this point, that point right there, then I'm going to do up 2 and over 1. So my slope is going to be 2 over 1, or just 2. And if I did the other side, this point right here, I did 1, 2 over, that will give me a negative 2. Okay. So the question is the slope positive or negative? Well, again, if you look at the actual graph itself, the actual graph does this, which means it's a minimum. And since it's a minimum, then we know that a value has to be positive. So then we know slope has to be positive, so we're going to use this guy right here to write our equation. So the function, again, is going to be f of x is equal to 2 absolute value of x minus negative 1 absolute value plus 2, which becomes 2 absolute value of x plus 1 plus 2. Okay. And so it's a shift left. It's a shift left. Let me erase some stuff real quick. It's a shift to the left and up. So again, I should see a shift to the left and a shift up. Okay. So now if I want to evaluate 4/5, I take my equation, and I'm going to write this as small as I can. 2 times the absolute value of 4/5 plus 1 plus 2. And again, use your calculator on this if you're not too sure. And if you're doing this in fraction form, it's going to become 2 to the absolute value of 9/5 plus 2. So again, the absolute value of 9/5 is still 9/5, so that actually doesn't change. So again, 2 times 9/5 is 18/5 plus 2, and that's going to give me I think it's going to be 28 over 5, but I want to make sure about that. Yeah, 28 over 5. So again, f of 4/5 becomes 28 over 5. Okay? Again, use your calculator, folks, to do fractions, decimals if you're not comfortable with them yet. Ultimately, I'm going to tell you, you're going to probably want to get comfortable with fractions by hand if you're going to be taking things like SAT tests on the road. But again, that's neither here nor there right now. Okay. All right. So that's the general idea. Anyway, moving on. So here we go. What happens if you're given 2 points? Okay, so the first thing is, again, I know my information. Here's my vertex. I know the second point right here. So right off the bat, I know my vertex is going to be -3, -2. Okay, see if I can write a better 3. -3, comma, -2. Okay. What is a slope? So here's the thing. You're going to want to plot your points 1, 2, 3, 1, 2. There's -3, -2. And then the other one is 5, -12, which goes off the graph. 10, 11, it's about right here. Okay. So that's going to be 5, -12. And you're going to want to find the slope. Now, I'm going to show you 2 methods at this point on how to find slope, okay, if you can't use a reservoir run. But here's the other thing I'm going to tell you. You have to remember that there is an axis of symmetry that goes right through here, like this, which means that this point is symmetrical on the other side. So what happens is, if I know that this is 1, 2, 3, 4, 5, 6, 7, 8 units that way, then on this side I should have one that is 1, 2, 3, 4, 5, 6, 7, 8 units, and it's going to be somewhere down here. I don't know exactly where, but I do know what this tells me is that my graph is going to do this like this. And it's not a perfect graph, but I know the graph is going to do that because of that. So my axis of symmetry tells me that I have a point on either side of it, makes it symmetrical. Okay. So what that does also tells me is the fact that my A value has to be negative. Okay. So right off the bat, I know my slope that I'm going to use has to be negative because of that. Okay. So now how do you find the slope? There's 2 methods. Since I have 2 points, the first method I will show you is to use the actual equation that you have. So for example, if this is HK and this is XY, if the graph or the equation basically says it's Y is equal to A X minus H plus K, then I can use the numbers I have to fill it in where it's Y, I'm sorry, let me go back one, where Y would be -12 is equal to A, which I don't know, plus X, which is 5, 5 minus h, which is negative 3, minus 2. And then I work this out. And if I work this out, you know, this is minus 12 is equal to a. That becomes 8 minus 2. You know, I add 2 to both sides. So you have negative 14 is equal to a. Absolute value of 8 is still 8. So divide by 8. So I know that my a value is going to be a negative 7 over, oops, let me do this again. 7 over 4. Okay. So that would be my a value right there. This guy right here. Okay. Method 2 is to use my points again the same way, but use the slope formula instead. So then I could do something to the effect of negative 12 minus negative 2 all over I'm trying to see if I did something wrong right now because I'm trying to pay attention to what I'm doing. 5 minus negative 3, 5 plus 8, negative 12. Add 2, add 2. Oh yeah, apparently I cannot add. Take a step back here. If you caught what I did, that's good. It's a mistake, and I didn't pay attention to what I was doing a minute ago. And that's my fault. Something didn't make sense when I was doing this. Right here, when I add 2, this becomes a negative 10, not a negative 14. That was just a mistake on my part. Divide by 8, so this becomes a negative 5, 4 is equal to a. Okay. I apologize for that. That was just a mental error on my part. But anyway, and I noticed that because when I was doing this, it didn't make any sense. And then you have 5 minus a negative 3, which gives you a negative 10 over 8. And again, you still get the same answer that a is equal to negative 5 over 4. Okay. So either way you choose to do it, it doesn't matter to me. Pick one and stick with it. I'm going to say the first method is a method that you'll use in another unit going down the road. The second method is one that, unless you have a straight line, won't work really for anything else. Which, guess what? After this, we really don't have a whole lot of straight lines. So I would say get used to method A, or the first method, but again, if not, for right now, at least know one of them. So then my equation is going to be negative 5 over 4 absolute value of x plus 3 minus 2. Okay. Anyway. And also, that's a good check on yourself. And that, like I said, that was just a mental error on my part, just not paying attention. So if you did one and you got something on the second one, then check something because something's not right. That happens. All right. So moving on. Moving on. To my favorite problem. The word problem. Yay. All right. So, same idea. I'm not going to sit here and read the whole thing to you, but with the idea being that you want to find your vertex, find your slope, write the equation. Okay. So I'm not going to read it to you, but you can pause and read it real fast if you want to do that. Okay. So here's what I do know is the fact that right here, it actually tells me that the depth is 240 feet, 48 feet deep from the shore. That tells me that the vertex is this point right here. And so that my HK is 240 negative 48. Okay. I also know that this point right here is a good point to have because that means that I can find my slope really fast. It's not going to write on that. But anyway, that's 0, 0. Okay. So my slope and I'm actually going to use method 2 on this one because I have 0, 0 as my point, which makes this so much easier, is basically negative 48 minus 0 over 240 minus 0. So basically my answer comes out to be a negative 48 over 240, which basically becomes, and I'll tell you here in just a second, I believe it's 1/5. Yeah, it's 1/5. Negative 1/5, okay? But here's the problem. The graph itself is a minimum graph, meaning that my A value has to become a positive value for it to work right. So if I write my equation, it's going to essentially be f of x is equal to a positive 1/5 absolute value of x minus 240 minus 48. And then it wants me to determine the depth at 360 feet. So I take my same equation, 1/5. Oh, let me do a different color here on this right here. Let's do green. 1/5 absolute value of, what did it say, 360 minus 240 minus 48. And then when I do all the math, I figure out the depth itself is going to be, well, let's see what it's going to be. 360 minus 240 is 120. Absolute value of 120 is 120 divided by 5 minus 48. It looks like the depth is going to be minus 24 feet. And again, if you want to pause it before I did this, try it out to make sure you get the same answer that I did. That's always a good thing to do. Let's call it, practicing. All right, last thing. Okay, last thing. And this one won't take as long. Okay, and essentially it's writing a transformation graph equation from a transformation. So the graph shifted 3 units right, 2 units down. So 3 units right, 2 units down. That's my vertex point. And it's vertically reflected about the x, which means it looks something like this. I don't actually know where the points are at. But if I want to write an equation for that, what I do know is my vertex is x minus 3 minus 2. And since it's vertically reflected down, this is going to be negative. And you could write a negative 1 if you want. It won't hurt anything if you did. Okay, that's just not calibrated now all of a sudden. There you go. Makes my absolute values big, like that. Okay. The second one, let me see if I can get a better picture of this because apparently I'm off screen. There you go. The second one, and again, if I read the graph, has an axis of symmetry at x equals negative 3. So at x equals negative 3, there's an axis of symmetry right here. Okay, x equals negative 3. And it has a y value of a negative 6. Okay, so if I go to negative 6, which is going to be, let me change a different point color, which is going to be right here. But it says it's a maximum point, which means that the graph does this. Okay. Since I know that my axis of symmetry is here and my vertex point is here, I actually know my vertex is going to be, oops, that's okay, negative 3 and negative 6. And again, I also know that A is going to be negative 1 in this case, because I don't actually know there anything else. I also know that it has a vertical stretch of 4. So when I write my equation, it's negative 4 absolute value of x plus 3 minus 6. And again, I'm going to double check everything. Axis symmetry is at x equals negative 3. It's a maximum point, and the y value is negative 6. So that fits, okay? So there you have it, folks. That's how you write equations of absolute value. So that's what you'll be working on today. Again, as soon as you have any questions, let me know. You know where to find me. If not, y'all can just get a hold of me somehow, okay? All right. Other than that, I got nothing else for y'all. So good luck.